Welcome to my algebra class. We're on chapter 11, section 6, and we're going to be working with the Pythagorean theorem. The Pythagorean theorem states that the two sides of a right triangle, which we call the legs, if we square those sides and add them together, they'll equal the side across from the right angle, the hypotenuse squared. So if we want to find a missing side, in this first problem here, we would have a squared plus b squared equals c squared. So 6 squared plus 8 squared has to equal c squared. 36 plus 64 equals c squared. And that would be 100 equals c squared, and then we take the square roots of both sides. And since this is always positive, we don't want the negative value, so 10 equals c. We're measuring distance. In the second example, this one here, we're missing a leg, so it'd be 8 squared plus b squared equals 20 squared, the hypotenuse squared. So 64 plus b squared equals 400. And then to get b squared by itself, we would need to subtract 64 from both sides. So subtracting 64, we get b squared equals 336. So b equals the square root of 336. And I don't believe that's a perfect square, but we'll double check. And I believe the problems ask you to, let me double check if they ask you to round to the nearest tenth. Yeah, they're asking to the nearest hundredth. So rounding this one to the nearest hundredths would be 18.33. You can also use the Pythagorean theorem to determine if the lengths given make a right triangle. So on this next example here, if we want to see if 4, 8, and 10 make a right triangle, we can use the Pythagorean theorem. The two smaller sides would be the legs, and they would have to equal the longest side squared. So that's 16 plus 64, and that's 100, and that does not add up, so that's not a right triangle. We could do 15 squared plus 36 squared and see if it equals 39 squared. 15 squared is 225. 36 squared is 1296. And 39 squared is, whoops, I think I got something wrong there. 39 squared is 1521. And that we're ready to start the problems. So get your paper headed and, whoops, wrong one. Turn to page 532, and we're doing 1 through 16 even. Make sure you have the title down. So problem number 2 on 532. We're using the right triangle in the paper to the right. Find the missing length correct to the nearest hundredth. You use your calculator. So I'm going to slide this over, pull our calculator over here. So problem number 2. A is 5, so we're going to have 5 squared, plus b is 12. 12 squared equals c squared. So we have 25 plus 144 equals c squared. That adds up to 169 equals c squared, and we take the square root of both sides. Remember, we just want the positive square root. And 169 is a perfect square, so hypotenuse is 13. Problem number 4. A is 13, so a squared plus b squared plus equals c squared. A is 13, so 13 squared plus b 9 squared has to equal the hypotenuse squared. 13 squared is 169. 9 squared is 81. So adding that up, we get 250 equals c squared. Take the square root of both sides, so 250, square root of that to the nearest tenth is 15.81. Problem number 6. A is 16. So we have 16 squared plus b is 9 squared has to equal c squared. 16 squared is 256. And 9 squared is 81. Add that together, we get 337 equals c squared. Take the square root of both sides. And to the nearest hundredth, it'd be 18.36. Did I add that right? Let's see, 256, I don't think I added it right. 256 plus 81 is 337. And the square root of that is let me check something here. $17.89. Okay, 337. Take the square root of that, it's 18.38. Oh, I see what I did. This should have been 8 squared. It took me a second here. So that's 64. And that's 320. And the square root of 320 is 17.89. Problem number 8. A is unknown. B is 11. And the hypotenuse is 87. So we have a squared plus 11 squared has to equal 17 squared. So a squared plus 121 equals 17 squared, which is 289. And we subtract the 121 from both sides. So we get a squared equals 168. And we take the square root of both sides. And to the nearest hundredth, it's 12.96. So that's the missing leg. Problem number 10. We have a given. It's 5 squared. B is missing. One of the legs is missing. And the hypotenuse is 8 squared. So we have 25 plus b squared equals 64. Subtract the 25 from both sides. and we get b squared equals 39. Take the square root of both sides, and to the nearest hundredth it's 6.24. So b equals 6.24 approximately. Problem number 12. State whether or not the three given numbers could represent the lengths of a side of a right triangle. So we have number 12, 3, 9, and 11. So the two smaller sides squared have to equal the largest side squared. So that's 9 plus 81 equals 121. And we can see 90 does not equal 121, so no. It's not a right triangle. Number 14, we have 16, 32, and 36. So 16 squared plus 32 squared would have to equal 36 squared. 16 squared is 256. And 32 squared is 1024. And 36 squared is 1296. And if we add these together, we get 1280 equals 1296. So no, it doesn't work. Problem number 16, we have 17, 34, and 39. So 17 squared plus 34 squared equals 39 squared. 17 squared is 289. And 34 squared is 1156. And last 39 squared is 1521. So if we add these up, 9 plus 6 is 15. That's 14, 4. That does not equal. So no. And the last 5 problems are word problems on page 533. So problem number 2, it says a guy wire 20 meters long is attached to the top of a telephone pole. So we have this pole, whoops, and there's a wire attached to it. And it reaches down to the ground 12 meters from the base. So we actually have a right triangle. And it reached 12 meters from the base. And the guy wire is 20 meters long. And they want to know how tall the telephone pole is. So we're missing one of the legs. So a squared plus b squared has to equal c squared. A squared plus 12 squared equals 20 squared. We have a squared plus 144 equals 20 squared, which is 400. Subtract the 144 from both sides, and a squared has to equal 256. Take the square root, and again remember this is positive, we're measuring distance, so we don't need the negative value, and 256, the square root is 16. So the length of the telephone pole is 16 meters. Problem number 4, the dimensions of a rectangular doorway so we have a rectangular doorway, are 200 by 90. Can a tabletop with a diameter of 210 meters be carried through the doorway? Well, if you turn it, the widest point is going to be the diameter, so if you try to slip it through here, you need to find out what the diagonal of this doorway is from here to here. So we take, we need to find C. So 200 squared is one leg, plus 90 squared is the other, because this is a right triangle, has to equal C squared. So that's 400. Excuse me, that's not 400. 200 squared is 40,000. Plus 90 squared is 8,100. Has to equal C squared. We add that together, we get 48100. Equals C squared. Take the square root of 48,100. And we get 219.31 approximately. And that's the biggest opening in that doorway, and the tabletop has a diameter of 210, so yes, it'll fit through there. That concludes the evens. Be sure you check the back of the book for the